Today is the day. Good evening, everyone. So, today is the day we are starting the new chapter in your life, right? So, guys, welcome to my physics lessons. So, today we are starting the physics classes for 2027 batch. I already did some introduction about my lessons, and today is the first class. I'm starting the theory here. Okay, right. I'm just giving you some introductions about advanced level. Okay, right. Advanced level physics. In advanced level physics, guys, advanced level physics, we are having like 11 units are there. 11 units. Okay, right. In advanced level physics, we are having 11 units. The first one is measurement. Measurements. The second unit is mechanics. The third one is oscillation and waves. The fourth one, thermal physics. Fifth one is gravitational field. Sixth one is electric field. Seventh one, magnetic field. Eighth one, electricity, current electricity. Ninth one, electronics. 10th one, prop. That means properties of matter. I'm writing like prop. And the 11th one is matter and radiation. Matter and radiation. Okay, right. So these are the units in advanced level physics. Okay, right. The first unit is measurements. Okay, right. We want to study about the measurements here. Right. I'm going to give you some introduction about these unit here, guys. Okay, right. In mechanics, today we are starting the measurements. In mechanics, guys, we will study about the linear motions. We will study about the motions like linear motion, motion under gravity, and also projectile motions, right? The second one in the mechanics is like force, equilibrium, center of gravity. Those part we will study. And then we will move to the Newton's laws of motion, momentum. We will study about the impulse. Those chapters are in this mechanics. After that, we will move to the work, energy, and power. Right? Circular motion is there, rotational motion is there, guys, and also some more like hydrostatics parts and Bernoulli's theorem. Right? Okay. Fluid dynamics. So those are the parts we are covering in mechanics. Right? Okay. I'm not giving you like a deep brief introduction about this unit. By the way, this is the first class, right? So I already did the introduction part. So I'm just giving you what are the chapters here. Okay, right. So subtopics. So look at this oscillation and waves. This is the third unit, guys. So in this chapter, we'll study about the waves. What kind of waves are there? Mechanical waves, electromagnetic waves. What are the characteristics of waves, right? What is simple harmonic motion? What is harmonic motion, right? Likewise, we will study those waves part. And also some other interesting parts also there, like Doppler effect. We are having Doppler effects and seismology. We will study those parts here. After that one, we will move to the light, right? So we can divide this oscillation and wave part into two. One is sound and one is light. Okay, right. So the light part we will study about the prism and reflection, lenses, and the instruments, optical instruments, we will study about those things here, okay, right, in oscillations and waves. In thermal physics, we will study about the heat, right, the energy, how the heat transfer from one point to another point, what is Newton's cooling law, right, and also what is specific heat capacity, how the heat conducts through the metals, okay, right, expansions, like lot of theories are there. We will study that part in the thermal physics. I am telling you just only few chapters, right? In gravitational field, guys, we study about how the planets are working. What is the force, how the force acting between two different masses, right? And how the satellite works. What is escape velocity, right? If you want to escape from the Earth's gravity, what is the speed I want to, what is the speed you want to travel, okay, from the Earth. So those kind of interesting parts are in this gravitational field. In electric field, we will study about the charge, the static charge, guys, okay. We'll study about the static charge, how the charges are moving, what is electric field, what is voltage. We'll study about those things in electric field part, and also we'll study about the capacity as well, capacitance, what is capacitor, those parts we will study in this electric field. In magnetic fields, study about the magnetic field, like how the magnet forms, how it's working, so like electromagnetic inductions, Fleming left-hand rule, right? So those kind of parts we will definitely study in this magnetic field, okay, right. Electricity. Electricity is all about, guys, moving charges. This electric field is about static charges, and this electricity is about moving charges, okay. So we will study the moving charges about the in this electricity part, okay, right. We will study the resistor, current, voltage, how to apply V is equal to I equation to the different kind of circuits, how the circuits are working, from where to where the current will go, and those kind of parts we will definitely cover in this electricity, okay. Like other one is like electronics, you already studied in all levels, right? PN junction, diodes, transistors, operational amplifiers, like lots of instruments are there. We will study about those things in electronics also, right? Okay, and also we will study some digital electronics as well, like you already studied in, if you take O-level IT, I think you hope you know the logic gates also, right? Okay, logic gates, we know that AND gate, OR gate, NOT gate, there are so many gates are there. So, and you studied about the truth table as well. So we will study those part in electronics, okay, right. In properties of matter. In properties of matter, guys, we will study three main topics. So one is surface tension, another one is like viscosity, the third one is elasticity. So these three parts we are going to cover up in this prop, okay. Sometimes you know that in a silent water surface, right, in a silent water surface, there will be some insect at the top of the water surface, that those insect didn't go inside the water, that is just floating, that's not floating, right, that is in the top of the water surface, right? Okay, that is a different type of concept. So we'll study those things in properties of matter, especially in surface tension, okay, right. The last part, matter and radiation, we'll study about radiation in this part, guys, okay, right. There is a connection between this thermal physics and matter and radiation, okay, thermal physics and matter and radiation. We'll study that one later. We'll study some particle physics theorem here, quantum physics, and black hole. We'll study, definitely we'll study how the black hole is working, or how radiation is forming, what is the unit of the radiation, so how it will affect the human body, those kind of parts are there. So this is full of interesting thing, guys, okay, interesting. Physics is an interesting subject, okay, right. Okay, so today the unit we are going to start here is measurement. So first of all, tell me, guys, why we are starting this chapter? What's the reason of starting this chapter, measurement, at first? There is a reason, because all of these units, mechanics, oscillation waves, thermal physics, gravitational field, electric field, magnetic field, electricity, electronic, prop, matter, in this, all of these units, we are going to study different kind of physical quantities. I'll tell you what is physical quantity later. We are going to study about lots of units are there, guys, right? Ohm, ampere, voltage, watt, joule, okay, Newton, meter second minus 2, meter second minus 1. There are a lot of Pascal, there are a lot of units are here. So we should know at first, before starting these units, these theorems, at first we should know how to measure things and what are the unit for those measurement. Okay, right, that is very important. Our subject physics is full of practicals, guys. So let's say if Newton said F is equal to ma equation, so that equation came from the practical. Okay, those equations came from the practicals. So likewise, many theories invented by the practicals. Okay, so when you are doing a practical, measurement is very important here. When you are doing a practical, measurement is very important. You should take a measurement, no? Each and every part you should take a measurement. So there is a measurement there. So if you want to do those practicals efficiently, correctly, you should know about the measurement, how to measure the length, how to measure the mass, how to measure the time. Within this time period, this electron is moving, like we should know how to measure the time period of that electron. Okay, right, how to find out the velocity of that electron. So likewise, there are lots of practical involving in our physics. Okay, physics units, in our units. So we should know about the measurements. So that's why, guys, we are going to start the first unit here, measurements. In this measurement unit, we are going to focus on two chapters. The first one is units and dimensions. Units and dimensions. The second one is measuring instruments. The second one is measuring instruments. Okay, right. So in units and dimensions, we will study about the units and the dimensions. In measuring instrument, we will study about different kind of measuring instruments. Those are vernier caliper, micrometer screw gauge, spherometer, and moving microscope. These are the main four measuring instruments. Okay. Apart from those, we will study about stopwatch, measuring tape, those kind of theories also there. Okay, we will study that part later. So let's move to the units and dimension. Okay, right. So in this video, if you are watching this video, the tute is the tute link is in the description. So you can check the description and you can download the PDF, guys. Okay, you can download the PDF and you can watch the, you can see the, while watching the video, you can see the PDFs as well. So please turn on the PDFs, or if you printed the tutes, you can follow the tutes. Okay, right. If you have the printed copies, you can follow it. So like we will start the lesson now, right? Okay, guys. So we are going to start the units and dimension here. Okay, first of all, take out your tutes. So in the tutes, we are going to start the first chapter, measurements and units and dimension, right? Okay, so look at the tute. In the modern society, obtaining measurements is essential to carry out any functions in an organized manner. Here the space is measured and the three basic measurements obtained are length, mass and time. So guys, this is the first thing we are going to study. Okay, right. So we know that when we are taking the measurements, what are the important main three measurements? Those are lengths. We should want to know or aware about the length. Okay, length is very important. The second one is mass. We should know about the mass, that is important. The third one is time. These are the main three measurement, guys. Okay, right. The first one is length. The second one is mass. The third one is time. So, let's go to the ancient time, before long ago, right? Okay. Long ago, like when the business started, how they did the business, like if I have sold 10 kilogram, if someone is having like 1 kilogram sugar, he gives the 1 kilogram sugar to me, I will give him 5 kilograms of salt or 10 kilograms of salt. This is how the business works. So at that time, what is the measurement you need, guys? You should know about the weight, how much you are giving to him and how much he is giving to me. So the weight is important here. Not only weight, the length. When I'm giving something like a wood or a steel bar, I should know about the length. We can't say that this much and this much, we can't say like that. So they should know exactly what amount we are giving and what amount we are getting. Okay, right. So we should know about the length and the mass, and also the time. The time is very important. Time is everything. At what time I need to wake up? What is my working schedule? Like the first, when the human came, when the human evolved, okay, right, they first aware about the time, because sun rays in the east and sunset at the west, no, right? So they know the time, so how long it will be take, right? Okay, how long it will be take, and after that they invented the clock and the sand clock and other stuffs. Okay, right, we will see that part later. Okay, so they should know about the time as well, as at what time we are going to work, at what time I need to return. So using the first time is the sun, right? They are looking the sun, so the sun is rising, so I need to go for the hunt or go for the work, like I need to go outside and do something and bring food to the family, right? So that is the starting time, and the ending time is sun setting time. So that is like the bio clock of the human, that is the nature, right? Okay, so these are the main measurements. Apart from these, there is nothing. Okay, they don't need to measure the velocity, they don't need to measure the force, they don't need to measure the pressure. Okay, only they need these main measurements. Okay, right. Look at the second note I gave you, history of weight and measures, right? First of all, I'm going to read you and then I'll explain you, okay? If you don't have the tunes, no worries, I'll read it and explain to you, okay? Right. Man had begun to use standard units for weighting and measuring purposes since before 400 BC. Since before, so they used these measuring instruments or the measurements since before 400 BC, guys. Long time ago, right? Okay. During that era, a weighting unit called stone weights. So this is the first weighting measurement. They use stone weight, guys, okay, for the weighting purposes. To measure the mass, they use stone weights. They use the stone weights. So you already know that. So in some small shops, grocery shops, you can look the stone weights are there. There are lots of stone weights are there. So for now, it is like 1 kg, 2 kg, 5 kg. There are lots of stone weights are there. In my childhood, normally when I'm going to a small grocery shop in my area, so definitely they will use the stone weight. Only after I think 2004 or 2003, they moved to the digital weighting scales. Okay, electronic weighting scale, they moved to the that one. So likewise, so before they use the stone weight, like they will keep some weight stones, different kind of stones. So there will be stone like this, like this, like this. So there will be some they keep some stones, okay, right, to weight the masses. Like this mass is like 5 stones, this is like 8 stones. So the shape of the stone and the mass of the stones are different to each other, no? So what they did here is they make some standards, like if it is a stone, that should be like this. Likewise, they maintain a standard, and those weights they used for the weighting purposes, okay, right. So at first they use stone weights, right, had been used to measure the weight of gold treasures stored in the temple of Egypt. So at first they used that to measure the gold treasures in Egypt, okay. So normally they will keep the in Egypt, like they will keep the all of the treasures under the pyramids, no, right, inside the pyramids, no. So at that time they use stone weight to measure the gold, silver, likewise, okay, right. And also the distance from the elbow to the end of the middle finger of the Pharaoh of Egypt has been accepted as a standard unit called cubit. So how they measure the length? They use the length between elbow and the end of the middle finger. So which is elbow? This is the elbow, end of the middle finger here. So this is 1 cubit. Okay, this is 1 cubit. In my childhood, like in 1998 to 2002 2003 period, most of my like grandmothers, grandfathers, they use this cubit to measure the paddy fields or any other area. They use the cubit, okay, right. So cubit is like this. So this is 1 cubit, this is 1 cubit, okay, this is 1. So how to measure that? If it is 1 cubit, this is the second one, this is the third one. So I can say that this length is like 3 cubits. This length is like 3 cubits, okay. This is how they measure the lengths. So they use cubits to measure the length, okay, like this. So this is the cubits. Can draw here. So this is 1 cubit, okay guys. Assume that this is a hand, okay, okay, right. Assume that this is the hand, right. Okay, so this is the elbow, no, right. So this is your elbow, and the length between the elbow and the end of your middle finger, right. This is cubit, guys, okay. This is cubit. Cubit, right. Okay, so these are the, in 400 BC they use these kind of measurement to measure the length and the mass, okay, right. At around 500 BC, a standard unit is called the mile, had been used in Greece and Rome. So in Greece and Rome, they are introducing the mile, okay. They are introducing the mile here. Again, they are introducing the mile to measure the like the length, okay. Still in some part of like US or UK, they are using the mile, guys, okay, right. Like in Kandy also, like in Kandy or Colombo, in some part of village areas, they are using 5th milestone, 6th milestone, 40th milestone. Likewise, they are still using the milestone, guys. Okay, they are still using the milestone. We will study later about what is the relationship between 1 kilometer and 1 mile. Okay, we will study that one later. Okay, right. So they use the mile as well. Okay, mile as well. Right. So in some part of USA, America, so they are still using this mile per hour. to measure the speed. Okay, some like we are using in cars, we are having like kilometer per hour. No? Some of the part in like in USA, California, or any other places, they are using in their cars, they are measuring the speed by miles per hour, right? Okay, so like 50 kilometer per hour and 50 miles per hour, those are different, right? Which is the highest speed, 50 kilometer per hour or 50 miles per hour? 50 miles per hour is the highest speed. Okay, we study that one later. Okay, right. So from the cubit, they are coming to the miles. They are coming to the mile. The unit mile is very much similar to the distance of mile we use today. So today we are using the mile. No, that is similar to this mile. Okay, right. In 890, in 890 AD, King Alfred of England established a standard unit called foot. You already know this one, guys, right? Foot. What is foot? The length between the ankle and the end of your finger in your leg, in your foot, right? Okay, that is 1 foot. So this is 1 foot, guys. So this is 1 foot. Okay, 1 foot. This is 1 foot. This is leg, right? Okay, this is your feet. Okay, right. So this is 1 foot. Normally, still there in some measurements, we are using the foot like when we are measuring the ground or a small space, still they are using the feet there. Okay, right. Normally, in height also we are using, right? If I am say like if I am 5 feet 11 inch or 10 inch, at that time we are using 5 feet. No, feet mean like 5 foot, right? Into 5. That this is the plural of this foot, no, right? Feet. So that is how it's going to work. So again they are moving to the foot. Again they are moving to the foot here. Foot. Right. Look at the next one. Foot in order to measure the length. In 1130, King Henry I of England established a length measuring standard unit called yard. Okay, right. And then time is going on. The measurement of length is also changing. At first it was cubit, and then mile, and then foot, and then they are coming to yard. Okay, and then they are coming to yard. And created a standard length using an iron bar. Okay, so what they did here is they introduced the measurement yard, and what they did here is they create an iron bar, one iron bar, a single iron bar. The length of the iron bar is 1 yard. The length of the iron bar is, guys, 1 yard. Okay, right. So this is the standard now. Like before they use like foot and cubits, no. What is the problem between the foot and the cubits? When you are using the foot and the cubit, guys, human to human, person to person, it can change, right? For me, the cubit is different from this point to this point. If someone take the another cubit, so if someone take the another measurement, that will also different. Foot, my foot is different. Other humans, other person's foot is different. So if it is like 20 feet, someone can take like a smaller foot person can take like it is like 25 feet. Okay, right. So person to person, it can be changed, but these are not standards. Like we can't say that this is a constant value. So it can be changed. It can be changed. This can be changed, right? Okay. So the yard, what they did here is they used a standard iron bar. Okay, right. So the problem is now over. No? We know the standard length of that iron bar. No? What's the problem now? Right. The problem here is with the iron bar. Iron bar is not a exact value, like it is not standard value, guys. because the corrosion will happen to the iron bar. Due to corrosion, the length can be increased or can reduce. Okay, right. Both can be happen. We will study those part later, right? Okay, and then if there are some scratch happen, the length will change. So due to corrosion, the length can change. Due to the thermal expansion, in summertime, the length is different. The winter time, the length is different. So in summer, it can expand, and in winter time, it can shrink. Okay, so those are going to change, guys, due to the weather. So due to the weather, they are changing. No, 1 yard is changing. No, so those are not standard. Standard means due to any other reasons. Due to any reason, it won't be changed. Okay, due to any natural disaster, so any chemical reaction, so anything physical changes, it can't be changed, it won't be changed. That is standard. So this is not standard there. Still, that is not standard, but comparing to the cubit and the foot, this is good, because cubit and the foot, person to person, it can be changed, no, but the yard is, it is comparatively, it is okay, right? It is okay. So time to time it is revolving. Okay, it is revolving, right? Please continue the story. Okay, right. Yeah, and created a standard length using iron bar in 1150. Okay, right. King David of Scotland interpreted the average value of the width of the thumb of 3 common men as a unit called inch. So again, we are coming to the inch, right? Inch also can change, no? For a common man, the width can be changed, right? Person to person, it can be changed, right? And declared it was the standard unit for measuring length, right? In 1324, King David II of England redefined the inch and declare it as the length of 3 barley seeds. So one person is telling like inch is like width of 3 common man. So that's not going to work. Person to person, it's going to change. Okay, and then they are saying like 1 inch is equal to 3 barley seeds length. So if we say like, if this is the barley seed, 3 barley seeds. So this is 1 inch. Okay, this is 1 inch. Again, after yard, they are coming to the inch. After yard, they are coming to the inch, guys. Okay, right. Okay, so inch is also, it can't be a standard, because what's the problem here? Barley seeds length can be changed, guys. Due to time, it can be changed. Right. Okay. So likewise, it is happening. Right. A committee constituting of French scientists appointed at the time of the French Revolution during the time period of 1789 to 1799 suggests the metric system of weighting and measuring purposes in 800. The standard unit of measuring length is the metric system is meter. So in 1800, guys, they are introducing the measurement meter. Okay, they are introducing the measurement meter. So look at this one. Look at the revolution of the length. Measurement of the length. Cubit, mile, foot, yard, inch, meter. Okay. This is how those measurements are revolved. Okay. Right. Okay. So meter was first defined as a fraction of a crore of the length of a line drawn from North Pole to the equator across the city Paris in France. Okay, right. Actually, look at this one, guys. This is an interesting one. Okay, so you know the equator, right? Okay, you know the equator. This is the equator. So let's say this is the North Pole. I'm drawing a line from the North Pole to the equator through the Paris. Okay, through the Paris. Through the France near Paris. Okay, right. I'm drawing. This is Paris. I'm drawing a line from the North Pole North pole to the equator. This is the equator, no? This is the equator, right? So we know the length now here. We know the length between these 2 points through the Paris. Okay, right? 1 crore. Okay, what they are telling here? A crore of the length of the line. A crore, right? So what you want to do here is you want to measure this line and you want to divide that by 1 crore and you will get the value. No, that value is equal to, guys, 1 meter. That value is equal to 1 meter. Right? Okay. So that is also not a standard value, guys. It can be due to some reasons. It can be due to like some astronomical changes or like many reasons are there. I'm not going to go into that part deeply. So it is also not a like standard value. Okay, right. In 1889, the General International Conference on Weights and Measures, GMP, met of the first time and interpreted the meter, and it was known as the International Meter. A prototype of both the meter and the kilogram were produced and they were installed in the International Bureau of Weight and Measures, BPA, located at Sevres in France. Okay, right, near Paris. These prototypes were made by the alloys of platinum and iridium and were produced up to very high accuracy. And then what, at the end of that this story, what happened here is in 1889, guys, the international standard for the length is meter. They are introducing it as a meter, right? Meter. For the meter, what they did here is they introduced a length using a bar. It is from like platinum and iridium. So those are like those are won't change, like those are won't expand to the heat that much. They will expand, guys. Those are little bit, okay, right? So those are not easily corrode, right? Those kind of things are there. So that's why they are introducing the platinum and the iridium. And for the 1 kilogram also, they use the standards. So this is 1 kilogram. For the weight, they use some stones here using the iridium and the platinum. For the iron, for this bar also, they use the same thing. So this is like 1 meter, right? So after that, what they did here is, guys, they said that for the length, the international standard unit is meter, and the mass, the unit is kilogram. They introduced the kilogram, guys. This is how the measurement, this is how the length, mass, time evolved, right? Okay. So what about the time, guys? Normally time, they measured using seconds. These are the units. So for the length, it is meter. For the mass, it is kilogram, SI units. For the time is seconds. Okay, right. Physical quantities. So we are going to move to the physical quantities, guys. Okay, we are going to move to the physical quantities now. So I'm going to erase these things. I'm going to erase this one. Right. Okay. Now I'm going to move to the physical quantities here, students. Physical quantities. Physical quantities. Okay. First of all, what is physical quantity? Tell me. What do you mean by physical quantity? If a certain property in a physical system can be directly or indirectly measured, it is known as physical quantity. Okay. What they are telling here, if a certain property is in a physical system, can be directly or indirectly measured. So what are the quantities we can measure directly and indirectly? What are the quantities we can measure? Like we can measure using the meter ruler, we can measure the length. So length is a physical quantity. We can measure the mass. Mass is a physical quantity. We can measure the time. Time is a physical quantity. So we can measure the time by the stopwatch. We can measure the mass by the weight scales. So like these are physical quantities. What are they? Others, like we can move for the other things as well, like electricity is a physical quantity. We can measure the current, no. Voltage is a physical quantity. We can measure the voltage, no. Speed is a physical quantity. Velocity is a physical quantity. Displacement is a physical quantity. Acceleration is a physical quantity. Force is a physical quantity. Momentum is a physical quantity. Likewise, we can say there are lots of physical quantities are there. We can measure the quantities, we can measure directly or indirectly. Those are physical quantities, guys. The quantities we can measure directly or indirectly are physical quantities. Okay, right. So there are number of hundreds of physical quantities are there. Right, hundreds of physical quantities are here. Okay, right. So this is known as physical quantities, guys. Right, we'll move to the physical quantity later. Before that one, I gave you a next note. Look at the note, guys. Necessity of units. So basically, what is the necessity of units, guys? What is the necessity? Why we are using the units? What's the reason? Because let's say we are telling like two physical quantities, like length and the mass. Without units, we can't say what is that. Like 100 what? 100 meter means there is a clarity, no. 100 meter. So this length is like 100 meters. So the track is like 100 meters. So there is a clarity. So the track is 1000, 10,000. What do you mean by that one? One leg. What do you mean by that? We don't know if it is centimeter or millimeter or meter or we don't know what is that. So this is why the physical quantity is important. Another thing. So if someone is saying like 10 kilogram and 10 meters, so there is a difference between the kilogram and the meter. No, both magnitudes are same. 10 kilogram, 10 meters. Look at this one. Okay. So 10 kilogram, 10 meters. So both are different. I know that this is weight, and this is length. How I know that this is weight and this is length? Using the units, no. Without units, we can't say anything. Without unit, look at this one. Without units, 10, 10. So without the units, I can't say that which is what. Okay, right. So these are the problems here, guys. So I'm going to tell you the necessity of the units. A clear idea about a certain physical quantity is not given by just expressing only the magnitudes. Okay, we can't say like, we can't give a clarity to the measurement without telling the units. With the magnitude, we can't tell anything. We can't pass the informations as well. Okay, right. To express a physical quantity with a clear, meaningful idea, it should be presented with a unit. Declaring that the width of the river is 100 doesn't convey how wide the river is. If the width of the river is 100, we don't know which is like 100 millimeters or 100 centimeters or 100 meters or we don't know the width, right? 100 kilometers. Sometimes we don't know, right? So we don't know the depth or we don't know the wide of the river. So if you want to know that one, we should introduce the unit there, right? Okay. But when it is expressed in a manner such as the width of the river is 100 meter, then a clear idea is implied. Okay, right. So if it is 100 meter, we know that this much is the river. We know that we are having a clarity, no? Right. Okay. All measurements possess the following features. Number one, an introduction to and a knowledge to the relevant physical quantity. We can get an introduction and a knowledge from that physical quantity by giving it a unit. Okay, without units, we can't say anything. We don't know what kind of physical quantity, if it is a length or if it is a mass or if it is a time, we don't know. Right, that is the first one. The second one, a process of comparing the magnitude. We can't compare the magnitude without the units, no. 10 centimeter and the 10 meter, those are very big difference is there. 10 centimeter and 10 millimeter difference, 10 millimeter and 10 like kilometers. There is a very big difference. So this is why the units are very important. Right, a process of comparing the magnitudes. So if you want to compare the magnitudes, the unit is very important. Like if I say like 1 meter is one, if I'm saying like 1 meter and 10 centimeter, which is the greatest one? 1 and 10, with looking at the magnitudes, if this is 1 and if this is 10, like both are, which is the biggest one? 10, no, the magnitude. So we can't say that this is highest value because this is 10 centimeter. So we are giving the clarity to that. This is 10 centimeter, this is 1 meter. 1 meter is bigger than 10 centimeter. While comparing to the 1 and 10, we can't say anything. So that is the point there, the second one. The third one, a general standard unit. Okay, a general standard unit. So we want to maintain a general standard unit. So that's why. Right. So the other note I gave you, essential features of standard units. Essential features of standard unit. I gave you some brief introduction for that one. So I'm just giving you like accessibility, invariability. The third one is reproducibility, and the fourth one is indestructibility. Okay, right. So these are the essential features of standard units. Okay, right. So anyhow, you should know that what is the importance of the measurement and the units here, right? Okay. So next one we are going to move to the move to some different kind of measuring units. Okay, different kinds of measuring units. So like guys, country to country, the measuring units are different. Country to country, the measuring units are different. Look at the first one. I'm going to tell you one measuring unit. Look at this one. System of feet, pound and second. This system is known as FPS. This system is known as FPS. FPS, okay. In this FPS system, guys, in this FPS system, this is known as feet. This is known as pound. This is known as second. Right. Many countries, including England, use the system of feet, pound and seconds to measure the length, mass and time respectively. So in England, guys, they use feet for the length, they use pound for the weight, and they use second for the time, to measure the time, to measure the length, to measure the weight. So feet, pound and second. Okay, in England they use this one. Normally still they are using the feet and the pound in England. Okay, right. Let's go with the second down, the B part, the B. System of centimeter, grams and second. System of centimeter, grams and second. This system is known as CGS system. CGS system. C is for the centimeter. C is for the centimeter, G is for the gram, S is for second. There's no change in seconds, right? There's no change in the time, okay? For the time measurement, always they are using the seconds, right? Okay. So, look at this one. France and many other countries use the unit centimeter, gram and second to measure the length, mass and time respectively. Due to the regularity in this system, it was used more in scientific activities. After the French Revolution, guys, most of the scientists came from the French, those area, Rome, those area. Okay, right. So in those period, during that French Revolution, those period, most of the scientists came from here, most of the experiment carried by them, and at that time, guys, normally they use the centimeter, gram and the second, and at that time the scientific research and experiment, everything is done by the centimeter, gram and seconds, okay, at that period. See, the third one is system of meter, kilogram and seconds, MKS. MKS. This is the system we are using now. Okay, MKS system, international standard system we are using now here, guys. Okay, MKS system. By further developing the CGS system, before the CGS at UK, they used the FPS. After FPS, it's CGS. CGS is revolving and coming back to MKS system. By further developing the CGS system, the MKS system, which is the system of meters, kilogram and second, was introduced. Okay, right. So, what is the problem between using the different systems, different systems in measurements? In different countries, in Sri Lanka, there is a different system. So we can say that in Sri Lanka, if we are using like feet and gram and second, for the length we are using the feet, for the weight we are using gram, and for the time we are using second. What's the problem? What will be the problem there? There will be many problems because of the international tradings and the scientific research. Okay, right. We'll see that. We'll see. In France, I'm going to give you some example to understand it. Like Sri Lanka and the UK is going to make a trade between those two countries. Let's say, if we order 10 kilogram, like 1000 kilogram of from the UK, right? Okay, we can say like for an example, okay, right? For an example, if we order like 1000 grams of salt from the UK, if we order 1000 kilograms of salt from the UK, at UK, what they are using there? They are using the pounds. We are using kilogram, they are using pounds. If they send us 1000 pounds, that is a big difference. So, in international trading, there are some problems with converting the units. So, what I want to do here, I need to take all the orders, and what I want to do, I need to convert that to pounds to kilogram, and I want to send it to them. So, these kind of problems are there in international tradings, guys. Not only in international tradings, but also in the in the scientific research. Let's say like Sri Lankan scientist and UK scientist are working together for a solution or in research. What will happen? That person from UK person, that person will measure the length and like the grams or the weight in different units. I am using different units. So there is a conflict. There is a problem when we are conducting experiments, when we are talking, when we are discussing the research. So there are a lot of problems are there. So what is the end of this? So how to solve this problem? So we can solve this problem by an international standard. So all of the world, all of the country, all of the world, it's want to use the same international standard for each and every measurements. Like for the basic, like the mass, length and the time, they should use the same in internationally. Internationally, they want to use the same. For that reason, what they use, they introduce or they make the standard international system for the international standard for the units. Okay, right. Look at this one. Necessity of an international unitary system. Use a different unitary system of measuring purposes in different countries in an obstruction to the progress of science as well as to progress of human civilization. There are two basic disadvantages that will occur due to the usage of different unit in different countries. Number one, inconvenience that occurred in scientific activities conducted together by scientists all over the world and during communication among scientists regarding new invention and discoveries. The second one, inconvenience that occur during in international trade affairs. Okay, right, international trade affairs. So that's why they introduce international unitary system, right? Let's move to the international unitary system, the next note. Let's move to the next note, international unitary system. I'm going to erase this, guys. International unitary system. Okay, right. Okay, so at the second session of GPM conference held in 1960, the SI system was introduced by standardizing 7 basic units for scientific measurements. Units used in this SI system can be mainly divided into 5 categories. So the system divided into 5 categories. Those are, I'm going to write them here. Those are basic units, second one is supplementary units, the third one is derived units, fourth one is multiple units, and the fifth one is additional units. So these are the units, guys. They divide the system into 5 units, okay? 5 kind of categories. So we should know about this basic unit, supplementary unit and derived units. And also there are some multiple and additional units are there. While we are studying, while we are doing examples on this, we will study this one as well. I will give you, okay? Right. So first of all, we are going to move to the basic units and the supplementary units, okay? I am going to move to the basic unit and the supplementary units here, guys. Right. Let's move to the basic unit and the supplementary units. Right. I'm going to erase this one. Okay, right. So students, in basic units, there are 7 basic units are there. Okay, right. So I'm going to put a small table here, right? Okay, these are physical quantities. This is a column. Second one is like units. Third one is like symbol of the unit. Okay, right. Symbol of the unit. First of all, the first physical quantity, the first basic unit here is, okay, the first basic unit here is, guys, mass. Physical quantity. The first physical quantity here is mass. What is the SI unit for the mass? The unit here is kilogram, right? Kilogram. What is the symbol for the kilogram? The symbol for the kilogram here is simple K and simple G. Okay, simple K and simple G. Second physical quantity here is, guys, the length. Okay, the second one is the length. What is the unit for the length? The unit for the length here is meter. Symbol for the length is simple m. Simple m. Simple m. Right. Okay. The third one is time. The third one is time. What is the unit for the time here? The time unit for the time here is second. Unit for the time is second. The symbol for the second here is simple s. Why I am mentioning the capital and the simple? There is an important thing is there. That's why. Okay. Right. It is time second simple s. The fourth one. The fourth one. Electric current. Before that one, we'll go for the thermodynamic temperature. The fourth one is thermodynamic. Thermodynamic temperature. It is not temperature, guys. It is thermodynamic temperature. For the thermodynamic temperature, the unit is, guys, Kelvin. Kelvin, not degree Celsius. It is Kelvin. Okay, right. For the Kelvin, the symbol here is for the Kelvin, it is capital K. You should remember this one. It is capital K. Capital K. Right. The fifth one. The fifth one is electric current. Electric current. For the electric current, the unit here is ampere. Ampere. The symbol for the unit here is, guys, capital A. Capital A. The sixth one, we'll move to the sixth one. The sixth one is amount of substance. Amount of substance. The unit for the amount of substance here is mole, right? It is mole, guys. M-O-L-E, mole. The symbol here is MOL. Simple M, simple O, simple L. MOL. The seventh one is luminous intensity. The seventh one here is, guys, luminous intensity. The seventh one is luminous intensity. The unit for the luminous intensity here is, guys, candela. What is that? Candela. Okay, right. C-A-N-D-E-L-A. C-A-N-D-E-L-A. Candela. It is simple C, simple D. Okay, simple C and simple D. So these are the basic physical quantities. How many basic physical quantities are there? There are 7 basic physical quantities are there, guys. Those are mass, length, time, thermodynamic temperature, electric current, amount of substance, luminous intensity. Okay, right. You should know about this one. Definitely, you should remember these basic physical quantities. Okay, there are 7 basic physical quantities are there. Mass, unit is kilogram, symbol is simple K, symbol G. Okay, right. For the length, the unit is meter, the symbol is simple M. For the time, the unit is second, the symbol is simple S. Thermodynamic temperature, the unit is Kelvin, the symbol is capital K. Electric current, the unit is ampere, the symbol is capital A. Amount of substance, the unit is mole, the symbol is simple M-O-L. The seventh one is luminous intensity, the unit is candela, the symbol is CD. I think you already heard about the mass, length, time and thermodynamic temperature and electric current. In chemistry, you studied mole, right? You already know the mole. This is the interesting part. Okay, right. So, no one of the student, mostly 95% of the student, they didn't know about the luminous intensity because there's no any physical quantity we used in O level, ordinary level. Right. Luminous intensity means, guys, if you are having like bulb boxes, empty bulb box in your home, you can go and check. There will be a word luminant. There will be a word luminant. There will be a word luminant. Luminant means, or the luminous intensity is known as, guys, the amount of the brightness. So in this room there is a different luminous. In the outside there will be a different. So we want to know the brightness. No, we can't say that like this is very bright, normal bright, dark, very dark. That is not the exact value. That is not how we want to measure. We should measure using a different quantity. We should know the amount of the brightness. So to know the amount of the brightness, you should know about the luminous intensity. So that is, guys, luminous intensity. Okay, right. And then I'm going to move to the next one. That is, guys, supplementary units. That is supplementary units. Okay, right. So when I'm moving to the supplementary units, there are two supplementary units are there. So we already did this basic units. Now there are 7 basic units are there. Now we are going to move to the supplementary units. Okay, right. Here I'm going to write it down. Supplementary units. Supplementary units. Students, you should remember that there are 2 supplementary units are there. One is plane angle. One is plane angle. Okay, right. The plane angle, the unit for the plane angle here is, guys, radian. Okay, in O levels you studied like 2π radian, 5 radian. Can you remember? 2π radian, 5 radian, 5/2 radian, 5/4 radian, 5/3 radian, 5/6 radian. For the 30 degree, 60 degree, 45 degree, 180 degree, 360 degree, you already studied, right? Radian, yeah. That is plane angle, right? Plane angle, the unit is, guys, radian. It is radian. Okay, radian. The symbol for the radian here is simple A, simple R, simple A, simple D. Simple R, simple A, and simple D. Okay, right. The second one is solid angle. Solid angle. Solid angle. So the second one is solid angle. For the solid angle, the unit for the solid angle here is, guys, steradian. Steradian. Okay, steradian. We'll write this, write like this. Steradian. For the steradian, I can say the unit here is simple SN, simple R. This is the symbol of the unit. Symbol of the unit. So, guys, these are the basic units and these are the supplementary units. Okay. You should remember all of these 7 and 2 units. These are basic units. Those are supplementary units. Okay. Right. So, we'll remind this one: mass kilogram, length meter, time second, thermodynamic temperature Kelvin, electric current ampere, amount of substance mole, luminous intensity candela. For the supplementary units, plane angle, the unit is radian, and the solid angle, it is steradian. Okay, right. So, guys, these are the basic and the supplementary units, right? Okay. After studying this one, we are going to move to the what? Derived, multiple, and additional unit in our next session, guys. So these are the main thing we studied today. In our next session, we will study about the derived units, multiple units, and additional unit. Okay, right. Okay, guys, let's wind up the lesson. You should remember these things. These are very important for the exam also. In final exam also, there are lots of questions based on this one. In the next class, I'll try to do some question on this one. I'll definitely do past paper questions as well. Okay, right. And also please follow the YouTube channel here, because I will put some more physics relevant videos here, guys. You can follow the videos here. And also, if you wish to join my physical classes, you can join number 0 handy. Okay, right. Or you can watch the recordings as well of my classes. that is a hybrid class. I'm doing the hybrid classes number 0 Candy. You can join with online or the physical. You can attend the class, physical classes or the online classes. You have both facilities. Okay, right. Okay guys, so let's wind up the class. We'll meet in the next session. Thank you so much. Bye.